Hello everyone, this is Amir from Audio Science Review. Today I have a special treat for you. It's a review of a brand new headphone amplifier. It has balanced output and unbalanced output. It's from Topping. It's a A30Pro. It's a companion to the DAC that I just recently reviewed. A lot of these look the same, so let me point out a couple of things that are special about this. One thing is power supply is built in, which is great. You don't have a dongle hanging on the side. There's a ground lift switch, which is unusual to find on these. If you have a nasty ground loop, especially on RCA connectors, you can play with this and see if it solves your problem. These things are very hard to get rid of when you get hit by them, so anything can be good to have there. These act as both headphone amplifiers and a desktop preamp, in that you can take the input and then bring the output out either as RCA outputs or TRS quarter-inch so-called headphone plugs in the back also. Usually these are balanced XLRs, but here we don't have enough room in here in this medium-sized chassis, so they went with this, which is fine, and the pros may like this better anyway, since they may have those kind of connections. The front is the usual affair, on-off switch, and whether you have it in the you have the XLR input or RCA output input in the back. Remember, there are two inputs, and 3 separate gain switches, low, medium, and high. The low is actually less than 1-to-1, which means that this, even at max volume, it will reduce levels, which is quite useful if you have some IEMs that are sensitive, and you can set it to that mode, and then you work in the volume control in the higher range of it, where the two channels match a lot better than if you had a lot of gain. You'd be forced to operate it way down in low level, and that can cause channel imbalance in these kinds of amplifiers. Anyway, as I said, there's balanced output, this Pentagon, and an XLR output, and a regular quarter-inch. One new thing from Topping is this hole pattern on top, tons of ventilation. We should tell you that this thing probably produces a fair amount of power. So with that out of the way, let's take a look at objective measurements and listening test results. Let me explain some of these measurements also as I go through them as sort of a tutorial in addition to the review. The way I test headphone amplifiers is that I put in what is called unity gain. Unity gain means I tell my audio precision analyzer to generate X voltage, and I then adjust the volume on the headphone amp to produce exactly the same output voltage. So in case of balanced devices, the nominal value for balanced input at full amplitude is 4 volts. So I set the analyzer, audio precision analyzer, to 4 volts, and then I adjust the volume to get 4 volts. And if you look in here, you see that it's essentially producing 4 volts. It's an analog control. I can't get it exactly to be that way. So all of my tests are this way. It kind of makes it fair because every headphone amp has a different gain, so it becomes arbitrary then to decide at what level do you measure the output. So the convention I've set since start has been that input and output matches. If the device only has unbalanced RCA inputs, then I set it to 2 volts because that's the nominal value for that. This has balanced XLR, so I've set it to 4 volts. So that is set to 4 volts. It requires medium gain. As I mentioned, the low gain requires creates an attenuation, which I don't want. I want unity gain. And using that, you can see in here the distortion, how many zeros it has. It's like, wow, 4 zeros in here. That's actually a problem with these distortion numbers. The eye glazes over all these zeros, and it's hard to remember what they are. So a much better way of looking at this distortion, the THT plus N, distortion plus noise, is to convert that to a decibel value. And it's just a simple math formula that gives you that. And we get a minus 120 as a number if we converted that to a decibel. But then if we throw out the minus, it becomes what we call a SINET. So these two right-hand side panels are identical information. They're not different measurements. They're the same measurement, one expressed as percentage, which is hard to remember, but the other one is expressed as a decibel and 120. And the higher the number, the better on this thing. If we go up here, the analog output of the amplifier is captured by the audio precision analyzer using some fancy math called Fourier transform. We can actually look at the spectrum of frequencies that are in there. Perfect output. This is our 1 kilohertz tone, this major spike. In the middle, this is actually our desired signal. Everything else is undesired. We have an undesired second harmonic and a third harmonic and fourth and fifth. Second harmonic is at minus 135. Remember from my previous videos, minus 115 is all we need. Anything more than that is gravy. So this distortion is utterly inaudible and definitely not a concern at all. And, you know, that's the second harmonic. Third and fourth are just way down in the noise. So that distortion is much lower than this SINAD number, which tells us that it's noise that is taking us from minus 135 up to 120. So put a pin in that. Let's look at where this 120 ranks. I've got this table of all these amplifiers that are headphone amplifiers that I've tested. And you can see that it slots number 3 up here, but the difference between number 1 and number 3 is only half a dB or something like that. So it's just completely in the noise. This is basically state-of-the-art, as state-of-the-art can get. And ironically right now, Topping owns all 3 top slots in here. Now, from audibility point of view, remember, you know, all the way down to 115, these things are all transparent. So it doesn't mean one is audibly better than the other one, but means that somebody really sweated the midnight oil, try to squeeze every bit of noise out of this noise and distortion out of this amplifier. If we use that same unity gain setting and measure the signal noise ratio, we see that the signal noise ratio is 127 dB. So this is like 21, 22 bits of dynamic range. Remember, CD is 16 bits, so we're up to 22 bits in here. We can never get to 24 or even higher than 22 at room temperature. There's just too much noise in electronic circuits to go beyond that. And also my analyzer has noise. This is actually combined noise from my analyzer and the amplifier. So it's really beyond good. But I also run a much more critical test and a practical test where instead of having 4 volts coming out, I dial the volume all the way down till I get just 50 millivolts out. So this tiny voltage out. And then I run the same test. Naturally, noise now has a higher percentage. So we go from 127 to 94. 94 is basically very much close to 96, which is the best case dynamic range of 16-bit CD, which means that if you're listening to just 50 millivolt output, you're still getting the full dynamic range of CD before you hit the noise floor. This is right now the top ranking of any amplifier, headphone amplifier that I've tested. This is the most quiet amplifier you can get. If you have very sensitive IEMs, in-ear monitors, they can be, they need just a trickle of power to produce signals. So the background noise of the amplifier can indeed become audible. A lot of times people complain and say, well, you show me inaudible stuff. No, no, no. When it comes to these little headphones that are stuck in your ear and right near your eardrum, even slight amount of hiss becomes audible. So you really do need something in the 90s at least, if not 93 90 to 95 in this graph, to have inaudible hiss, no matter how sensitive your IEM or headphone might be. So we have superb response in here. Headphone amplifiers have a relatively easy job when it comes to frequency response. And here I measure up to 100 kilohertz, so 5 times higher than hearing bandwidth. And we see a tiny bit of roll-off in here. For stability reasons, there's feedback in these things. You do at some point want to roll off the frequency response. Otherwise, you get into oscillations at high frequencies and nasty things happen. So every amplifier that's designed typically has some filter, but that filter, you want it to be high enough where an audible range of the 20 kilohertz is dead flat, which is what we have in here. So bandwidth is there. This also says this amplifier is transparent from frequency response and tonality point of view. Everything from near DC all the way out beyond hearing threshold is, beyond 20 kilohertz is flat. One of the most important things in headphone amplifiers are these power versus distortion and noise. You could argue if anybody can hear the distortions that I talked about earlier or the noise level. But when you push an amplifier, at some point it gets to its limits. And once it gets to its limits, nasty things happen. Like if you look on the right over here, you see this all of a sudden distortion shoots up all the way to max. So clearly this kind of distortion is audible and you want to avoid it. So we plot the distortion plus noise versus how much power we're producing and want to make sure the amount of power that we produce is way beyond what we need. Now with headphones it's tricky in that you can get a headphone that may be 12 ohms and you can get a headphone that may be 1,000 ohms. So these portable amplifiers have to handle this wide range of impedances. And what that means is that when the impedance is very high, you need voltage to get power. If the voltage is too low, because you take the voltage and square it, you divide it by resistance, you get the power. And if the voltage is too low, that's the numerator, it'll bring your power down. So for these high impedance loads, you need a lot of voltage. And indeed, this amplifier has an incredible amount of voltage. It produces nearly 0.7 watts. To give you an idea, your phone probably puts out 2 or 3 milliwatts. A headphone dongle may put out 10 milliwatts. This has 700 milliwatts. My threshold for a good amplifier, minimum that I like to see, is 100 milliwatts. And this thing is putting out 7 times as much. What's nice about this is that means in unbalanced mode, it's able to power any headphone you're going to throw at it. A lot of times the power in unbalanced is low and you have to use the balance connection to get this kind of power. And that requires getting new headphone cables for your headphone. And some headphones you can't replace the cable, so you can't convert them to balanced. Here we have incredible amount of power. I don't think I've ever seen a headphone amplifier that has this much power. And then when we look at down here as far as performance, the first headphone amplifier to break new ground in distortion and noise was the Massdrop THX 888 789. It's a design that THX came up with and Massdrop or drop.com licensed. And at the time, this was revolutionary. And you can see that in this dash blue line. You know, fast forward a year and a half later and look at this Topping A30Pro. In low and medium gains, in this green at the bottom you see, is way quieter than that state-of-the-art amplifier that was a year and a half ago. And if you put it in high gain mode, it then produces a little bit more noise than Massdrop THX, but then it goes way past it in power to produce this 0.7 watts before it clips. Importantly, if you use medium or low gain, it never clips. So if you're listening to it at any volume and you hear distortion, it's in your music. It is not in this amplifier. Now, as I said, the impedance range of headphones varies a lot. So we want to go to the other extreme and also test low impedance loads because that emphasizes current. We don't need a lot of voltage, but when we impedance, the resistance of the headphone gets small, then current becomes the dominant and limiting factor on how many watts you can induce into the headphone. So I go from 300 ohm load, and I change my load then that is connected to the output to 32 ohms. This says 33, but I've changed it now to 32 ohm. And we see a similar picture again. In low and medium, in green and blue in here, performance is just superb. No clipping, and noise is well below THX reference. And then in high gain, again, it busts the door open. It produces 5.5 watts per channel simultaneously driven. You only see one line in here. There are actually two on top of each other. And that's just incredible. We get 11 watts of power we're going to pump into a headphone. I'll talk about my listen test later, what happens when you try to do that. But this is just a ton of power. It's just remarkable how powerful this little amplifier is. Now, there is, as I mentioned, there is another way of connecting headphones, which is instead of having a common ground and the two leads going to each headphone, you can, if you separate the ground, and so each cup now has two independent wires, you can power them differentially. It's called balance. That's incorrect. It just means differentially, which means in theory you can get 4 times the power. Many times that's needed to get high amount of power. In this case, the power is so high that if you go in balance mode, you get 800 milliwatts, so a little bit more than unbalanced. But you don't need it, and the amp is limiting itself, and it won't go any higher than that. So in this case, the balance connection is a convenience, not a necessity with this unit. With many others, it can be a necessity if you have inefficient headphones. And then for convention, for the low impedance balanced, I use 50 ohm load, and we get 3.4 watts, so plenty of power in here. Channel balance is a big deal with headphone amplifiers in that if you have a very efficient headphone amplifier, headphone, you turn the volume way down here, and these are analog controls with 2 wipers on a carbon track. And as you get to the lowest amount, just the accuracy is not there, and all of a sudden you may notice a channel shift from one to the other, which can be pretty annoying. And so I measure for that. I turn on the amplifier, put it in max volume, and I manually turn the volume control. And the graph in here by Audio Precision Analyzer is plotting the output levels. So as I turn the gain down, and I'm doing it by hand, so it's not, precise line, this level is dropping. Meanwhile, I've also instructed the analyzer to look at the difference in the output voltage of the 2 channels, so we can see if they get out of whack. At the lowest level, as I mentioned, all of a sudden, the imbalance shoots way up here to more than 3 dB, which is quite audible. But up to about this point in here that I've got the cursor on, it's less than 0.5 dB, and that's my threshold. I don't think you can hear a channel shift that's only half a dB. So at half a dB, if I go down here, look at the red line, we've reduced the volume by 50 decibel, which is a ton of attenuation. So in the sample that I have, this is wonderful. This is very accurate. You're not going to notice a channel imbalance. Unfortunately, these resistors are not guaranteed to always have great performance, and some may be worse than this. And so the sample that you get may not be this good. But in this case, it's okay because you have this low gain mode. And when you're running it in low gain mode, you're operating it in this wider region where it's much more accurate. So I don't think practically you're going to have a problem. Topping makes a much more expensive device that has this R2R ladder relay-based system that is guaranteed to be accurate. So if you really, really have to have 100% accuracy, you're going to need to spend a lot more money to get that because all those relays and precision resistors are not cheap. Speaking of cost, unfortunately, I don't have the cost for this, nor the shipping date. I almost always have this information, but Topping sent these to me, and then the Chinese New Year happened, and they're off till later in February. So usually they give me production equipment. I don't accept prototypes or samples. And so I think once they come back, this will be distributed. So I think shipping date is very quick. What the cost is, I don't know. I'm guessing that it's in this medium chassis, so it'll be medium price. There's the, smaller form factor series they have. That's at, about 2/3 of this thing. Then they have ones that are full size. So I'm thinking this is reasonably priced. We'll find out, but my guess is $200 to $300. But we'll have to find out. I apologize for not having that religious about having that information. And just this one time, I forgot, and by the time I asked, the Topping people were out. Now, while I don't do listening tests for DACs, I always do listening tests for headphone amplifiers because it's very easy for me to characterize at what volume these things fall apart and get distorted. And just like the measurements, I have two special headphones I use for this testing. The first one I use is a Massdrop or Drop.com Dan Clark Ether CX. It's a closed headphone. I use this because it's has only 25 ohm output impedance, and it's rather inefficient. 25 ohms is a killer for most headphone amplifiers. The ones I recommend always do well with this, by the way. That's my sort of a litmus test. And it had no trouble here. The A30Pro just drives this like, it's not a difficult load whatsoever. So no problem. I had it in high gain mode, and you sort of ride it between 10 and 12 o'clock level if you want to listen loud. And the definition, detail, resolution, any way you want to quantify it, it's just exceptional. This amplifier just has no, it is just pass through. It's just amplifying and doing nothing else to your music. So if you have well-recorded music, and I've got a set of reference clips I use for this, it's just a delight to listen to. So that's for low impedance. We want to also then test high impedance, and there's no more popular headphone for high impedance than Sennheiser HD650. And so I always switch to this. And if the amplifier has trouble driving high, producing voltage, this always brings it out. And boy, was this a new experience for me. A lot of people laugh at me because I crank it up for the 1 or 2 seconds to test an amplifier just to make sure that it doesn't get distorted. And a lot of people say, well, you're going deaf. I'm not going deaf because I only do it for 1 or 2 seconds. With this amplifier, I could not go to max volume. It just was scary, scary, scary loud. I went to about 3 o'clock, and it was for just half a second, but I could just tell, something was, like plungers going into my ear as far as loudness. And it just was superb fidelity. I wish you couldn't damage your ears so you could listen at those crazy levels. But yes, you absolutely can lose your hearing with powerful amplifiers like this. So that's where their gain switches in the front. Use them in low and medium gain. But the high gain's there because they are piggy headphones. When I do my headphone reviews, I've been starting to collect how sensitive they are. And you can see the range in here from this NAD HP50 only needs 55 millivolts to produce 94 dB SPL. But then there's some piggy ones in here like the Spare Dynamic DT990 and requires 700. And we'll see as I test more whether we find more. But some of these are high impedance headphones and they are very, very inefficient also. And that seems to be the norm, these bigger cups and bigger headphones, and they're not very efficient. So it is good to have a headphone amplifier you buy once and you don't have to replace it. You may go through a bunch of headphones because you don't like the sound of one, you go to another. You want a headphone amplifier that has both current range and it also has voltage range, which means you can drive low impedance headphones and high impedance headphones. This not only does that, and a number of other headphone amps these days do that, but also just goes above and beyond. And so you're not going to have any trouble with longevity of your investment. Let me finish this with one note. The headphone amplifiers these days are DC coupled, means there's no capacitor on the output. They want to allow you to have frequency response all the way down to DC, basically. And when you do that, if something gets damaged inside this, it can produce DC and it can blow up your headphones. There are extensive protection circuits in these, both the components they use and usually externally, to protect against that. Occasionally, though, with some of the topping products specifically, there's been a couple of examples of that protection circuit not being strong enough and damaging a couple of people's headphones. They've really gone to town, from what I hear, to try to make this as safe as they can. but it's not something I can test for. You know, thousands of people buy these and then 3 people find problems. So if you're worried about that sort of thing, wait till somebody else, others buy them and we hear about reliability issues. Certainly my testing, I found no problems whatsoever, but I just want to make sure that you know about this and you don't jump in and then come back to blame me. I'm only here to test the performance of these things from engineering point of view, not from reliability and even functionality point of view. Okay, well, that's the end of this review. Got a little longer than I thought. Thanks for stopping by, and see you in the next review. Bye-bye.